All right, what's going on, y'all? Sean of Masswalk Tutoring here. And in this video, we're going to start talking about the topic of logic. And this is a geometry topic. And the reason why it's a part of geometry is because in geometry, you talk about proofs where you have to prove whether or not certain kind of things are true or not true or whatever. And so that comes later, but you have to talk about this topic first. Make sure you like and subscribe, and let's get into it. Now, pay careful attention because a lot of details in here, and it's not. It can be confusing if you don't really pay attention to all of it, but we're gonna make it make sense for you. All right, so let's put some terminology out here. So first of all, where do I want to go with this? All right, so say for example, you have the letter P, and P stands for like a statement, like literally a sentence. So, for example, if I were to say, um, Macon is in Georgia, Macon is where Math Tutoring is. Macon is in Georgia. That's a statement. Okay. You also have what would be called the negation of that statement. That's the symbol. So the negation of the statement. So again, so this would be Macon is in Georgia. I don't know why this is writing like that. The negation of this statement is Macon is not in Georgia. Okay. All right. So this statement, P can be true. We're just going to say T for true. Um, or P can be false. Okay. So when you have whatever statement that P is, just keep in mind that statement can be true or it can be false. Okay. Now, and also keep in mind that the negation of a statement is exactly the opposite of the statement. Okay. Now, let's throw in some other terms. I'm gonna put a line here and let's keep on going. Now, conjunction. So a conjunction is, and I'm gonna put the word and here. A conjunction is um a connection of two statements using the word and. Okay. So I'm not sure why this writing is doing like this. This application isn't working right. Okay. And so here's the key. For a conjunction to be true, both statements must be true. Okay. I'm gonna have to type this because this is not really making my writing accurate. All right. So what does that mean? So say for example, this is where the concept of truth tables comes in. Say for example, you have two statements. P is a statement and Q is a statement. Okay. Say that we want to find out what P and Q is. Now, P and Q is denoted by an up arrow. Okay. For a conjunction to be true, both of these statements must be true. So if we say that P is true and Q is true, then P and Q is true because that's what a conjunction says. This has to be true and this has to be true for the whole conjunction to be true. Therefore, if this is true and this statement is false, then the conjunction is false. If this is false and this is true, still false. And then if this is false and this is false, this is false. Again, we know that because the only time that a conjunction will be true is if both statements are actually true. Okay? All right, let's keep it going. Now let's talk about a disjunction. I'm going to use the word or. So a disjunction, I'm going to type this out here. A disjunction is a connection of two statements using the word or. Okay. Now, so for a disjunction to be true, at least one of the statements must be true. And if you think about that, it makes sense. So if you say, for example, roses are red and the dirt is purple. I mean, roses are red or the dirt is purple. It's telling you one of those has to be true for the whole thing to be true, right? Okay, so now let's construct the truth table for an or. Now, or statements, disjunctions are denoted like this: P or Q with a down arrow. So remember, one of these has to be true for the whole thing to be true. So true, 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 um, false, then this is still true. This is false, and this is true. It's still true. And then if both of them are false, then the whole thing is false. Because you have to have at least one of them to be true for the whole thing to be um, true. All right, good. So now let's go on to the next one, which is conditional, which is denoted by if, then. Okay, let's type this out again since this stuff isn't really behaving. All right. So, no, I don't want it to do that. Oh, it's going to do it anyway. Okay, so a conditional, really conditional statement is a connection of two statements using if, then. The if part is called the hypothesis, and the then is the conclusion. Okay. All right. Oops, I didn't mean to put a comma there. All right. So think about what a conditional is saying. If this happens, then this is the what happens as a consequence. If this hypothesis occurs, I'm going to go ahead and write this over here. If P, then Q. So in other words, if P happens, Q happens. Okay. And this is denoted by P arrow Q. You can always also say P implies Q. If P happens, then Q happens. Okay. So now let's construct a truth table for this. Okay. So you got P, Q, and then if P, then Q. Now let's think about this. So if P happens, then Q happens. So if that's true and that's true, then you already know that the if P then Q is true. Okay, so what about if the hypothesis is true but the conclusion is false? So you're saying, so we know that for a conditional to be true, as we said here, the if has to happen and then the then has to happen. So if P is true, then Q is false. But we said a conditional is if P happens, Q happens. This says if P happens, then Q doesn't happen. But this is actually false because if this happens, this has to happen. If P happens, Q has to happen. Okay. And so that's why both true make a true statement. This says P happens, Q doesn't happen, even though it has to happen. And so therefore the conditional is false. Now, what about if you have P is false and T is true? All right, so if this happens, then this happens. Now, what if this does not happen? So in other words, P is not true. If P is not true, then does that automatically mean is it okay for true to be Q to be true? So if you think about it, it is okay because P being true is a condition for Q to be true, but it's not necessarily the only condition for Q to be true, if that makes sense. Okay. So this actually is true. And again, that's because P is a condition for Q to be true. So definitely if P happens, Q happens. Okay. That's why both of them being true is true. That's why the conclusion being false is false. Because if P is true, then Q has to be true. Okay. However, if the hypothesis does not happen, it doesn't necessarily mean that the conclusion is not going to happen. Okay. So likewise, if P is false and Q is false, think about that. Again, if P is if P then Q, if this happens, this happens. So if this doesn't happen, this still could happen or it could not happen. It could be either. So that's why this if then and this if then are true. Okay. All right. So let me give a practical example for this one because this can be a little trickier than the other two. So let's say you have if it storms, we don't go outside. Okay. This is our conditional. So if it storms, we don't go outside. That is what makes that just is. Okay, so if it storms, we don't go outside. So say that the hypothesis it storms is true, and we don't go outside is true. That is a true statement. All right. If the hypothesis is true, but then this is false, let's think about that. So that's saying if it storms, not that we don't go outside, we do go outside. So that does not work because if it storms, we're not supposed to go outside. Okay. So that is false. Now, what if this is false? What if it does not storm? Does that mean that we don't go outside? Well, it could. It could mean that, but it could not mean that. So in each case of this being false, if it doesn't storm, we could go outside, we could not go outside. So in each of those cases, that could be a true statement. However, going back to the one false statement, because this whole thing is true for sure, if the hypothesis is true, this can't be the conclusion cannot be false when the hypothesis is true. Okay. When it storms, you don't go outside, period. Okay. So this is implying if it storms, we go outside, then that is false. Okay. All right. So let's see. Did I talk about everything I wanted to talk about in here? I think so. Let's go back up here, see what we have. Okay, yeah, there we go. So we talked about everything I wanted to talk about in this video. I strongly encourage you to watch this video again and again and again and again and again because of the fact that this stuff can be a little bit tricky, but it should make logical sense. By the way, it is a logic topic, so it should make logical sense. Okay. All right. Make sure you like this video. Make sure you comment. Let me know how it was for you. Make sure you subscribe to the channel. Make sure you share and also make sure you have a good day. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.